for a tutorial on molarity. You should have, for class, you should have the notes that go with this, and so you can fill in. These notes are the second page of the notes that were given on Thursday. So molarity is the most common mole-based concentration unit. Molarity, symbolized with a capital M, is defined as the number of moles of solute per liter of solution, or put into an equation or formula we can understand, molarity, capital M, is the moles of solute divided by the liters of solution. And what's great, and that we'll see momentarily, is that because we have a ratio of moles of solute to liters of solution, this will present itself as an excellent conversion factor in future problems that we'll encounter. So let's just dive right in. Example 1, calculate the molarity of a 2.0 liter solution that has 5 moles of sodium hydroxide. So again, we know our equation from up above. So our solution, no pun intended, we have the molarity for this sodium hydroxide. The moles is right there, the 5.0 moles of NaOH divided by the volume, which is 2 liters of solution. And when we do the calculation, we get 2.5 molar sodium hydroxide. So this molarity right there is read as molar. And so we'd read it as 2.5 molar sodium hydroxide. Let's go on and do another one with example 2. This one you have, it says to try on your own. So go ahead and take a moment, pause the video, and calculate the molarity of 2.5 liters of solution containing 0.75 moles of magnesium chloride. So pause the video now. Okay, great. Now that you've returned, if you actually did pause, we see the answer should be 0.3 molar. To show your work, molarity is the number of moles. So in this case, 0.75 moles of the magnesium chloride. And the volume is 2.5 moles, liters of solution. And so 0.75 divided by 2.5 is indeed 0.3 molarity. And if we're actually using significant figures here, it'd be 0.30. Okay, now it says in the next note right below, remember the need for conversion factors to convert from mass to number of moles. So what we're getting at is up above where we said, hey, we're going to have to think of this in terms of a conversion factor. And now that we have moles of a solute, you better bet that we're going to be using things of that solute, so molar mass, for instance. So example 3, excuse me, says if 5 grams of glucose are dissolved in 100 milliliters of solution, calculate the molarity M of this glucose solution. So we can do this one of 2 ways. One, I like to do it all in one T-chart, and I'll demonstrate that second. So first, we need to take our grams and convert it to moles, and then we can take those moles and divide by the liters to get molarity. So 5.00 grams of glucose, and then 1 mole. So the molar mass of glucose, you should know that glucose is C, I believe it's C6. Let's see, 12 times 6 plus 12 plus, yep, so it's C6 H12O6. I apologize for the brain fart there, but the molar mass here is 180 grams per mole. So 180 down here. And what this gives us is 0.0278 moles of glucose. And we can take that many moles of glucose and divide it by the volume, which is 100 milliliters, would be 0.100 liters, being sure to maintain the same three significant figures. So 0.100 liters of the solution, and our result is 0.278 moles per liter, or molar. Now the alternative, I said we could do all one setup, would be if we did this 5.00 grams of glucose, set up the T-chart, 1 mole over 180 grams of glucose, and then we can just say 1 over 0.100 liters. That would be fine, but if you prefer the top way, I am just as fine with that. Not a problem. Okay, so go ahead and try example 4 on your own. It says calculate the molarity of KCl when 2.33 grams of KCl are dissolved in 2.50 times 10 to the 3 milliliters of solution. So take a moment, pause the video, try it now. Okay, so if you did this, the answer that you should have gotten is 0.0125 molar. So the way we go about it, we have the 2.33 grams of KCl. 1 mole of KCl has 74.55 grams per that 1 mole. And so doing the calculation would get us 0.03125 moles of KCl. I'm not going to worry about significant figures here because it's an intermediate result. Then I divide this by the volume, which this many milliliters, it's 2,500 milliliters, is also the same as 2.5 liters. So if I do the math, what I get out is this 0.0125 molar for KCl. Okay, go ahead and turn to the back side to example 5, and then we're all set. There we go. So example 5 says to calculate the volume of a 0.750 molar sulfuric acid, H2SO4 solution containing 0.120 moles of solute. So now we want the volume. Again, remember molarity is moles of solute over liters of solution. So we're just doing some algebra here, doing some rearranging. So 0.75 molar equals 0.120 moles of the H2SO4 per X. X is our volume that we want. Multiply both sides by X. So 0.75 X equals 0.120. Divide both sides by that molarity. And what we get for X in this case is 0.160 liters. So we'd have 0.160 liters of solution for this 0.75 molar sulfuric acid solution. Now, go ahead, get to work on the practice set, and good luck.